All right, there you go. It looks like we're live. Hey, teacher. So here we all are. Me, Austin, and Colin are all here. Colin had a hard time figuring out the internet situation, so we are FaceTiming him. Here's the handsome guy. You can see him. Alrighty. Best we could do for right now. We'll promise to be better later. But, all right. So you, Austin, what were you saying about the group meeting? Basically,
we need to. 5 minutes
I'm sorry, man. I know. You're gonna be the one that echoes.
Then we got the 7 hour
But it's just so Colin can hear you, you know. It's just think of Colin every time you hear yourself. Okay.
It's annoying because like a second delay or something. Here it's just hard for me to concentrate. Then we basically do the whole activity and assignments together.
Okay. So under week 3, the day 5, the activity, there's that practicing integrals with power function. And just work on some of those.
Yeah, supposed to do all of them.
All of them, yeah.
Yeah.
That works. So, do you have that pulled up, Colin?
Yeah, I'm pulling it up right now.
Okay. Man. Looks like I just woke up.
Jealous?
No, I just need a haircut or something. Yeah, some of these get confusing, and derivatives and all of that.
Yeah.
Honestly, I'm not even sure if I feel comfortable enough to take an exam for them.
Yeah.
These are this is great though, because this is what I need to understand. I understand the linearization ones pretty well, the other ones, but these antiderivatives are kind of getting me right now. It's just a whole different set of rules. I'm not gonna be the smart guy in this.
It's hard to find all those rules for things. I'll throw that on the website.
Can't solve it yet. Nice. Oh. And I wonder if I still have that one thing. Okay, Colin, did you pull it up?
Which assignment?
Week 3. It's the activity A, I think, right? Okay, let me see here. So week 3, day 5, activity.
Week 3, day 5.
Activity. Yep. Due tonight at 11. Yep. Week 3, day 5, activity. Did you work through it yet, Austin?
I'm looking at hers. Damn.
Yeah, some of these like probably gonna have to use that substitution.
Yeah, it looks like they all do. One is U, two is Z, three is Z, four is U, five is U, six is Z, seven is Z. You can't do it yet. I don't know why we can't do it. Oh, I guess. 9 is just algebra. 10 is stuff again. I don't really understand these. To be honest.
Yeah, like I said though, before next week rolls around, I'm really gonna practice these because they're gonna, they're important. Oh boy. Did you find it, Colin?
You keep breaking up. I can hear from you every once in a while, but
can you hear me better now?
yeah, that's better.
Yeah. Did you find it? It was a week 3, day 5 activity. Yeah. Clicked on that, and then if you scroll there at the bottom, it's like practicing integrals with power functions worksheet.
Gotcha.
Yeah. So click on that, and it brings up a bunch of problems. You got that?
It.
Okay.
What's the difference between U substitution and Z substitution?
Yeah. Oh, so who's the most comfortable with antiderivatives, huh?
I've worked through the first.
Yeah.
I sort of understand what's going on. It's like do an example.
I think I understand it like halfway.
Yeah. So.
Yeah.
Number one.
Not quite there yet, but I will be. Let me see if I can see that right there.
That's just
Oh no, man! It's so bright. It's so bright. You can't see anything. Yeah, you're gonna have to either turn up the light or use a pen. Yeah, that'll be better. There you go. Right. I see the.
Okay. So
yeah.
So that.
Right. So since this is a U sub 1,
yeah.
U is just that bottom part. Right. I got you. U is x3 minus 1. You got it pulled out, Colin?
Yeah.
Yeah. Okay, so U is that bottom part there, x3 minus 1. Then we got to find the derivative of that, right?
Yeah.
It's 3x squared dx.
Yeah.
Right. And what do you do after that one?
This is very so yeah. This one you want to do what she's doing. and over on the side, so that you have the x marks the same. So you get, I don't know how to write upside down backwards. Du over 3 x.
So you want to get the x by itself there?
Yeah.
Okay.
So it's the same as the top.
Right.
And then you can plug in. So you got
Oh.
du over 3 and
So you want to make it the same as the top, you mean?
Yeah.
Du over, what did you, oh, u to the 5th. And then what did you write after that? 3.
Yeah, it's a 3. You're going to take du 3x. Du over 3 x plus dx.
I gotcha. I gotcha. Yeah.
So then you have the same thing on the top. So when you do the substitution, putting that into the.
Here, let me show Colin that one. Here, hold it up a little. Can you see it, Colin?
Yeah. Gotcha.
And then you can take the derivative of all that. That's the question.
Mm-hmm. Okay. Yeah. Okie dokie. So, yeah.
Is he saying stuff to process off here today. So the integrals are going to you. Then you want to top.
How did you get the 1/4?
Whenever you do the integral of that, it's going to be 4 to the 4th there, since it's on the bottom side.
Right.
That's where the 4 came from. It's negative.
What was the power rule for the anti ones again? So that's what you were using, right?
Yeah. I'm trying to figure out how to transfer from the bottom. Like, I see how it works. But
Oh, okay. That's what it is. Yeah.
I don't know how to explain it, but
Isn't it just the x to the n plus 1 over n plus 1?
I think that sounds right.
Okay. So if du over 3 is equal to x squared, right?
Yeah.
Then u times d. So then you do u to the negative 5 du over 3, right?
Yeah.
I'll put that up there.
Yeah.
That becomes u to the negative 4 over 3 times negative 4 doing the power rule thing. N plus 1, which is negative 4, negative 5. Yep. And then down there, plus 1, and then plus c.
Yeah.
Okay. And then you basically substitute it back in and flip it to the bottom. I got you now.
Yeah. That's what we're doing there.
I've got you. Sorry I'm so slow, man.
It's okay. I'm still trying to figure it out too.
Been a little bit.
So you said the power rule is x n plus 1 over n plus 1.
Yes. It's x to the n plus 1 over n plus 1 and then plus c to all of that.
Yeah. Okay.
Yeah. So
That makes a little bit more sense now. I'm just trying to figure out what I'm doing here.
yeah. So yeah, it gets tricky when you have negative exponents because you got to move them up and down.
Yeah.
Up and down sometimes. That back and forth. Yeah. But that u to the negative 5, like I said, becomes u to the negative 4, and then you have a 3 at the bottom, so you divide, and then you got the x or n, whatever you want to call it, plus 1.
Okay. Does anybody understand this substitution or no?
Colin, how are you feeling on those ones? Or
Not
we just
too bad. I mean, the only thing that I have is the same problem with you is moving those negative exponents up and down.
yeah. Gotcha. So yep. I mean, the nice thing is that you can always get partial credit, but you want to go all the way.
Yeah.
Finish the race. So yeah, when you move that u to the negative 4th down, and then substitute it and all that, you got the negative 1 on the top. Then the x cubed minus 1 to the 4th on the bottom. What am I missing here? I'm missing something. Oh, 3 times negative 4. Yeah, 12. Yeah, the 12 there. So, do you guys see how you get the answer there? Negative 1 over... I think that's what you had, right?
Yeah, negative 1 over 12 with that
x
thing in
cubed
parentheses.
minus 1 parentheses to the 4th plus c.
Yeah.
Yeah. All right. Well, that's a fun one. Man, if that's number one, number one, guys. Shoot.
It's gonna be a long day.
Oh man. Okay. Number two.
Do any of us know how to do the substitution before we move into that one?
Yeah, like I said, I'm gonna.
I say we do all the substitution ones first, and then go back and see after that. How does that sound?
Yeah, that works. Man.
Okay, so number 4.
Yeah, that's fine. I need a new piece of paper here. 4. Square is 4. Now the nice thing is that the product rules, they're the same, you know. Okay. So are you here? You know, I don't know if this is true, Austin, but I've heard before that we want it to be like the most complicated looking one.
Sorry. You cut out for a second.
Can you hear me now?
Yeah.
No, I said I don't know if this is true or not, but I heard that we want it to be like the most complicated one out of the two.
Yeah, you do to the highest power.
Of the highest power, yeah. So it would be that x squared plus 3x minus 1, right? Or u.
Yeah.
Or du is x plus 3.
Yeah. Right.
Okay, how did you get from u to the 4th to u to the 5th in that one?
Oh, that's using your using that thing.
Oh,
that's when you do that.
Hang on, hold that up, brother. Let me show you Colin right here, so you can see that. Can you see it?
Yep.
So basically, what I was saying. So we got this right here, right? We take this is our u here. We take the derivative of that. Then that's what we have right here. The derivative 2x plus 3. And then this is where I am. This becomes u to the 4th du. And now he was saying use this here to get this. So basically u, that's the x there, u to the n plus 1, so u to the 5th, all over n plus 1, which is 4 plus 1. So u to the 5th over 5 plus c. Yeah, thanks for doing that. Hold it up there for just 1 second, man. Plus c, and then okay. Now I got how you got that. Now we substitute the u. Okay, so you remember that the u, Colin, was this up here? So we basically just put that. Now that we got this, our equation here, we can plug that in right there. U to the 5th over 5 plus c. Is that the end of the problem there? I think that's the end. Yeah, that's the end of it. 3x minus 1. So basically with these u substitution ones, you substitute u for something really complicated so you can do the derivative of it without a problem, and then you plug it back in. And apparently that works in calculus. So that's nice. That's nice. Okay. What's the next U sub one?
Number 5.
Let's see. Number 5 one? Which one's that one? Oh, the 1 over root 4x minus 1 dx. Okay. Let's see here. Okay, so yeah, whenever they have that square root, I always like to change them in parentheses form.
Yeah.
That's like the first thing I do.
Yeah, I just did that immediately right here too.
To the 1/2, yeah. And let's see. So our U is 1. I'm just kidding. It's
Yeah, got it.
I'm just kidding. It's 4x minus 1. Our du is just 4x. And I'm so glad for these shortcuts because like I saw like how long it would take to actually take the derivative of it, like the OG way, you know, like the original way. So yeah. Okay, anyhow. Maybe I'll ask us to do that sometime. Let's see, so over U to the 1/2. So it's just U to the negative 1/2. Du, isn't it? So does it just end up being oh, right. And now we take the thing to it. Now that I did all of that. So you take the antiderivative of, wow, I can't talk. Antiderivative of U to the negative 1/2, right? Did I do that right, Austin?
Sorry. What do you have so far? Okay, so we got yeah. Okay. Correct. So that 4x there should
Yeah.
be 4dx. Because the derivative of 4x minus 1 is just 4. And then you check
Right. 4x dx. Yeah. Sorry.
Which will make a huge difference on your equation.
Yeah, and then
I'm trying.
you see that down there.
So you're missing when you do the du equals 4
dx.
You need to have the dx by itself.
Need to have the dx by itself. Okay. I knew I was missing something. We did that in problem number 1.
Yeah.
Yeah, du over 4 is
Then you
equal
can
to.
plug that.
Is it du over 4x?
Yeah.
No, it's just
4.
It's just 4. Yeah, it's just 4. Yeah, gotcha. Equals dx. Yep. Because the derivative is just 4. Yep. Okay, and then after that, let me see your work there again.
So then you go that and you
Right.
plug it in and get you. Where am I? To get you this.
All right, are we ready to plug that in yet, or?
Yeah, you can plug that in. So it should be something that looks like this. Integral du over 4u to the 1/2.
So du over 4u to the 1/2, right? And it becomes.
Yeah, my work. Sorry.
No, you're fine. So you canceled the d and the.
Yeah, integral and the du cancel each other.
The integral and the d cancel each other.
That's how you know negative that.
Huh?
And then
So yeah, so that's 1 over 4.
your u thing over here where it's the u plus of negative 1/2 plus 1 over negative 1/2 plus 1, which is what you do. So u1/2 over 2. And then you just plug that into with the 4, so that eventually.
Give me 1 second there.
There might be some more things I'm not very sorry. Does that make sense?
Almost. I just want to write it down so you don't have to keep pulling it up.
Yeah, it's okay.
Okay, you can put it down now. Yeah. So basically, what you were saying here. Okay, so du over 4 equals dx, right? I got that part. Then 1. No, not 1. Sorry. The d and the integral cancel out, leaving you with u over 4u to the 1/2. That's part of the original equation there. You just plug in the u.
Yeah.
The 1 up there.
The 1's just for the dx. So you say dx is on top.
Yeah.
So that's where you're doing the du.
Right. The one there doesn't impact it here.
Yeah.
So it's just u over 4u to the 1/2.
Mm-hmm.
Then where do you go from there?
So when you integrate it, you know your integration and du are going to cancel automatically.
Are we ready to plug in yet, or not really? Because we still have another u.
Yeah. So that. So you're sort of doing it's all like but that you plug in that you don't have to plug in that x plus. I mean the x to n plus 1 over n plus 1 formula.
Right. The n plus 1 formula. But we got 2 u's here in this one, right? We got one at the top and one at the bottom. The one of them just cancel out. Or what's going on here?
So that du is going to cancel.
I thought just the d is going to cancel.
The du is derivative of u.
Well, the derivative of u, right? That's what I was like. Wait a second.
So it's one term there.
Yeah,
du,
right. They're not separate, right? Okay, good. So, I was like, hang on a second. You're scaring me here, Austin. Yeah, you're scaring me, Austin. I thought they were separate. Now I'm like, hang on. Okay, the derivative of u. So just 1 over 4. Okay, now I can plug in right there. But I think I wanna. Do I wanna move that to the top?
I did.
Yeah.
Yeah.
What about the 4 on the bottom? So it's like u to the negative 1/2 all over 4, right?
Yeah.
So negative 1/2 plus 1 is equal to positive 1/2. And then 1/2 plus 1.
Negative
1 plus 1. Negative 1/2 plus 1, right? So it's 1/2 at the bottom as well.
Yeah.
Right. So I get u to the 1/2 over 1/2, right?
Mm-hmm.
Which, okay. And then do we multiply the 2 at the bottom to the top to get rid of the fraction, or do we just, just bring it down?
Yeah. So you get 2u to the 1/2.
Okay, yeah. So you get 2u to the 1/2, right?
And that's going to go back into your other. 2u to the 1/2 of that 4.
2u to the 1/2 over the 4, right?
Yeah. And then you just simplify it.
simplify that would be 1/2. So it'd be u to the 1/2 over 2.
Yeah.
Right? And then that's finito right there, right? Like we just gotta plug it in now.
Yeah, you just add C and plug it out.
So yeah, so you just plug the u. So the final answer is what? 4x minus 1 to the 1/2 all over 2 plus c.
1/2. Square root of 4x minus 1 over 2 plus c. Oh, sorry. Minus.
Mm-hmm.
1/2 square root of 4x minus 1 plus c. Yeah.
Nice. Oh shit. Did you lose the sound, man? Still? Darn. I think you're gonna have to FaceTime him now, man.
I am.
I think so.
That could be a pain.
Mine doesn't work.
Let's see. Good. Which one says the 267?
Yeah, no, that's mine.
286. Okay. What's going on here? Hold on. There we go. Up there. Okay. Oh. What happened? Can you still hear me? No.
Oh yeah. Yeah, no, that's the same thing. Yeah, I got the answer, man. That's the same thing. I just wrote it a different way. Yeah, I just wrote it a different way. I wrote it like that.
Yeah, that's basically. I just had the squirt.
Yeah, it's the same thing though.
You got sound right now?
Yeah.
Or are you still not responding. No. I think he's not responding. Yeah, that sounds like that.
What's that?
His internet sounds a lot.
Yeah, that's what it sounds like. Thanks.
So?
Well, so far the group meeting has been really helpful, honestly. I was a bit confused with the U sub and all that. You did pretty well explaining it. That power, those formulas for doing these derivatives are, I gotta memorize that. I keep forgetting that x to the n plus 1 over n plus 1. Why is that so hard? It's so easy.
It's just a little different, but
yeah, it's just different.
Once it's connected, it's like, oh, okay. But
yeah.
I don't know what to do about it.
Right, as far as calling it.
Yeah, we still got more of the here, I think.
I'm not sure either. Was that all the U sub ones, or?
I think there's
honestly, man, they all look like U sub to me. I don't know how you tell the difference.
Neither do I. But she has hey, like answer keys on but to see what the difference is. That's how I learned.
Oh, does that say it? Nice.
That's how I. You don't have put it.
All right.
So it's like trying to figure it out.
Well, thank goodness for that, then, man. I didn't even think about the answer key, man. That's
good.
That's good. That's gonna help a lot, though. Learning something the wrong way, that's even worse than.
Yeah.
Yeah. What's that?
Last is number 10.
Number 10. Okay.
I don't know how she though.
What's that?
I don't know how she can tell me.
Yeah, I'm not quite sure either, bro.
I see it. So Z substitution is whenever the X values are the same. And then
When the X values are the same, what do you mean?
yeah, like so number 7. I'm not sure that's stuff. There's an X outside, and an X inside, and then you substitute. I think. If that makes sense.
Like when there's an X outside of a parentheses and an X inside of one?
It's like number also an example where on top and then there's an X to the bottom. You can take the integral X.
Let me put these headphones back on so you stop freaking echoing. That's crazy. I'm sure you're tired of that.
So sad.
Give me a second here. I don't know how to plug this in.
So do we want to go through problem number 10?
Is that better for you?
Yeah, that's better for me.
Cool. All right. So, what were you saying again? For number.
So like number 6 is another example of a Z substitution, the X on top and then X minus 5 on bottom.
Right.
So if you were to take the integral of X minus 5, because that's a more complicated one, you just get 1, and that doesn't equal X, so there's no point in doing U substitution there. So what I think it is.
So you take the integral of the bottom one.
Yeah, because usually when you do U substitution, the thing you take the integral of will equal about the same power as the thing outside. Like everything we've been doing so far. Like number 4 is probably the best one to do it with. You take the integral of that bigger one, it gets you. I mean, the derivative of the bigger one, it gets you the.
It gets you the small one, 2x plus 3. And
that's how you know that you can do that.
That you can do U substitution.
Yeah.
If it didn't do that, then you wouldn't be able to.
You don't do U substitution.
You would do Z substitution.
That's what it's looking like. Yeah. So U substitution is done when it's X plus 1, or like X to the n plus 1. Like, so the X's, there's one that has a larger 1 by 1. Z substitution is looking like it's when it's the same power.
Yeah, because the derivative of X minus 5 to the 4th, that would be like something different than X.
Yeah, exactly.
That's what you're saying. Yeah, then the X on top.
And so then we don't know how to do that yet, basically.
Yeah. So what's with the Z sub? I know those are harder. Yeah, okay.
U substitution.
Okay. How's number 10? Is it friendly?
Yeah, it should be fairly friendly.
Let's say U is the 3x plus 1. Du is equal to 6.
We're doing question number 10. Because it's U sub still.
Yeah, 10. 10 is just 6x. Du is just 6x, right? 6x dx. 6x dx. Jeez. That dx, man. Always forget it. Okay. And then to get the x by itself is du over 6 equal to.
So,
is it du over 6x or du over 6?
It's just du over 6.
Okay, that's what I thought. It's equal to x dx, right?
Yes.
In this case, it's x dx. Okay. So now this is where the tricky part is. You go to the original problem and do. Oh, you don't go to the original problem yet. You just try to find the derivative of that, right?
Yeah, I think that's right.
of 1 over 6.
I'll tell you the answer here if you want to know. I'm showing it to him. I don't know if he'll have any questions, but that's the work. Well,
Let me see. No, I pulled up the answer sheet so I can see.
I should probably check that answer.
Yeah. Let me see. I don't think I can see it there, man. You gotta like pull it. Yeah.
Yeah, I was showing Colin.
Oh, there you go. There you go. Gotcha. Let's see here. Okay. U1 over 6. U2 times U2. Yeah, I see. I've got it. Yeah. I got you.
Is that making sense there?
Yep. U to the 4th over 6, and that becomes U to the 3rd. No, U to the 5th. Sorry, U to the 5th over 5 plus 1, which is 6. No, not 5 plus
1. It's 4 plus
4 plus 1.
Yeah.
It's 5. And then 5 times 6 is 30. So is equal to U was that big thing, x squared plus 3x minus 1 all over 30 plus c.
Yeah.
Raised to the 5, right?
Mm-hmm.
Raised to the 5th. Yep. Got it. Okay. Yusuf, you are my new friend. Substitution. Okay. So
let's figure out problem number 2 now and how Z substitution works.
Now we get to blow up our brains looking for oh, wow, you guys are texting like crazy. Oh yeah. Don't you worry, Colin. Don't you worry. We are. It's about. Okay, so which one are we working on now?
I'm looking at number 2.
Number 2, okay. Number 2, x root x minus 4 dx. What does the answer? How is due? Because yeah, C substitution confuses me. So.
Yep. We'll figure it out next time with him.
Okay, so is he going?
Yeah, he just bailed on me.
Gotcha.
I don't blame him.
Yeah. Apparently he's having internet issues. Seems like a nice guy though, you know.
Yeah.
So the Z is the big one this time, and it looks like the U is gonna be the small one. Is that what? Or we don't have a U.
No, there's not gonna be any U, I don't think.
Not gonna be any U in this one. It's just a Z. Okay. Oh. Okay, so the Z is x minus 4. And then we got to find out what x is equal there, which is equal to Z plus 4. Is what that's saying there.
But I gotta go right now. And it was great talking to you.
If x equals C.
Where did that come from? Oh, never mind. Oh, okay. My bad.
dx equals dz. How did they get that? Do you see it?
What was your question? Where at?
I'm like trying to figure it out with the answer key now.
Yeah, I'm just looking through it, like
What?
going through it slowly.
Yeah, what's that dx equals dz?
That's taking the derivative of that top one. So the derivative of x is dx, while the derivative of dz's side would be dz.
Oh, I see. I see. I
Derivative of x
see. I
equals the
see.
derivative of z.
Okay, gotcha. Because the 4 is just gone.
Integrate.
4 doesn't.
Like my code. So I know that in Seattle, but I'm going to do the same. Then I'm asking jobs that have any test.
Oh, okay.
I get. I was. Good job.
Like that, right?
Well, I mean, either way.
So
Okay, that's not too bad. I sort of like this a little bit better.
Yeah, you feeling better? You said.
I think this one's going to be a little easier than the substitution. I feel like.
Cool. So I see that x is the c plus 4, right? And then yeah, z to the 1/2 because it's the square root.
Yeah.
And z is x minus 4. And then trying to figure out why they put dz instead of dx. Oh, because they're equal to each other. It's equal to.
And then after you multiply them together, you're just the derivative of that.
So then you multiply them together, you said?
Yeah, after you plug the z's in and the dz or whatever.
Which would be just taking the derivative of them. Like the multiplication rule thing, product rule.
Yeah, so after you like multiply the z plus 4 times the z to the 1/2, you then do that power rule to both equate to like each section of the equation. That gets you.
That gets you the z to the 3/2.
Yeah.
Plus 4 z to the 1/2.
Yeah.
Okay. And then adding them together. Ay. Fractions. Gotta love them. Isn't that 4/2? How are they getting 5/2?
Yeah.
Okay, maybe just try to explain it to me slowly. You seem to get it. That'll work better.
It's a little bit better for me too.
Like you were doing with the use of that really helped, man.
So we went from. I'm just rewriting it so I can.
You're fine.
See where I am.
You're fine.
His mine probably looks fairly similar to hers right now, but. So you have you've done that so far, right?
Let's see. I'm at the.
You're at the
2 plus 4. Yeah, 2 plus 4. Oh, z plus 4. Sorry.
Yeah.
I'm at the top. I'm at the top part right there, and I'm not sure. One? Yeah, I'm at that one. I don't know how you got the bottom part.
No.
There.
So you're doing basic algebra here where you're multiplying this times that. So you're just factoring.
Okay.
So z times z to the 1/2 gets you z to the 3 halves. And then z times 4 gets you 4z to the 1/2.
Yep. Gotcha now. Okay, so it was just factoring.
Yeah, that's all it is.
Okay.
And then from here, you're going to do the n+1 thing on this one and the n+1 on this one right here. And
you get, let's see, z to the 2 minus 2. Okay, that's how they get the 5/2 over 3 over 5/2 again, right? Plus, what is that? 4z to the 3/2 over 3/2.
Yeah, so
right?
z to the 3 halves plus
And then
4z to the 1/2.
Yeah.
And then that's just the power rule thing from there on out.
Okay, they were. I see. Times 2/3. Yep. Let's see. Gotcha. Okay. Two over 3 plus c. Right, and then you start the algebra. All right, we can move on to the next one. Yeah, I got this one. If you want to do more, man.
I'm thinking about moving on to the whatever's next.
Go for it.
I have the general idea, and I think might as well work on the homework, and we can help each other with the homework. That might be the best, unless you're ready to call it.
No, I'm fine. I'm fine. I was just planning on meeting for an hour, honestly.
Yeah, that's all I figured. I didn't know how long it would take.
Well, what were you going with the? You mean the one that we did earlier today, the math lab one?
Yeah, because we have some sort of math lab homework due today, don't we?
Yeah, the math lab homework.
You want to do that together?
That was due at 12 though, at noon.
It was?
Yeah, they're always due at noon. You can pull it up. You can still do it. You know, get some credit for it.
The one for today's due at Monday at noon. Always do the next day at noon.
Which one are you talking
about? Week 3, day 5.
Okay.
I know the one yesterday was due at noon today. I got that. It's just due next.
I didn't think there was one due on Saturday.
No, it's not due Saturday. It's due Monday.
Oh, okay, the Monday one.
Yeah, so it's week 5, day 3.
I gotcha.
It's due Monday morning.
I've gotcha. Yeah, May 14th. Yeah, I don't think we got to work on that. But well, what's it about anyway? What's that one about?
I don't know. Let's see.
U substitution. Yeah. U sub. Well, at this point, I wish I could be more help with U sub, but you want to just try to do one?
You could. Which one is
double?
What is that?
9.
3 day 5 and it rolls U substitution, C substitution, 9 questions.
Yeah, let me go pull it up.
Hopefully they give us the same one.
If only we could meet every day, huh?
Yeah. Might be easier if we just meet up in person, I feel like.
Yeah, true too. That is true too. You know, I really don't mind that.
Neither do I. I'd rather
Yeah.
do that. Might be
Yeah.
okay doing it every day just to get everything done. That's up to you.
Yeah, bro. Might be cool. Maybe we can set something up.
Yeah.
So yeah. So here's the number 1. Are you in that one? The 2x x squared plus 7 3dx.
Mine's similar. I've got 2x to the x squared plus 10 to the third.
Oh, okay. So
But it still should be
pretty
less.
similar, same
Yeah,
thing.
it's just that
So
constant's different. It's which shouldn't matter too much.
Right. We take our u, which
Yeah.
is just x squared. The 7 disappears anyway. So you know,
Yeah.
u is equal to d. I mean, it's equal to 2x dx. So then you divide the 2 there.
You don't need to move the 2 over on this one because it's in the actual equation.
You don't need to move it to the other
Yeah,
side?
you don't, because in your original integral, it's 2x.
2x. Yeah,
So
I see that.
That 2x
So
dx just stays.
oh, I see it. I
Just
got
stays the
you now. Yeah, it just stays the same. Okay. Thanks for catching that for me.
No problem.
I see that now. Okay, so then we're ready. 2x, and then you plug in u to the third. Right? 2x, and then u to the third.
Yeah, sounds right.
But don't we have to take the integral? Don't we got to take the integral of that? Yeah, we do. You take the integral of u to the third, right?
Yeah.
Before we do that?
Yeah, so you have du u to the third.
Yeah.
You take the integral of u to the third.
Which is just u to the 4th over 4.
Yep. Then plug in and that's your answer.
Yep. And then what about the 2x on the side there? Don't you have to multiply that in there too?
2x is the du. 2x dx is u. So the 2x dx is
the 2x is the
du.
becomes du.
Yeah.
Let's see. Okay, so the answer here is just x squared plus 7 to the 4th all over 4 plus c. Yeah. Or in your case, plus 10.
Yeah.
Let's try that. There. Yep, we got it.
Oh,
I got it.
Plus c.
Yeah, don't forget that plus c, man.
It's like, why is my answer wrong?
Yeah, that c could be anything, you know? It could be anything. All right. Okay. And there's only 9 of these?
Yeah.
That's fun. I think I got time for one more.
Okay.
All right. So let's see here. The integral of 2x to the 4th all over square root 3 minus 4x to the 5 dx. Okay, u is that bottom one. Hopefully it equals 2x to the 4th, so we don't have to go into z.
This one does look like it should be a u because there's a 5 on, mine has a 5 on top on the x and a 6 on the bottom, or the other one.
Oh, yours is different than mine.
Yeah.
Oh, yeah. Oh, that's a fun thing about my math lab.
Yeah, it's like, just give us the same one, like.
Yeah, seriously.
What is that?
X to the 5th. To the 1/2. Okay. So du is equal to 1/2. I think chain rule over here, right? To get that derivative there. That's what I'm thinking.
For which one?
The chain rule for derivatives.
Yeah, I guess. I don't even remember what the chain rule was.
Oh man, chain rule is this one. I did it right here. So from that to that, where you
Oh,
basically do this guy and then multiply it by the derivative of the inside.
you don't need that 1/2 there.
This
You
one.
should just be the 3 minus 4x to the 5th.
Oh wait
That
a
1/2
second.
you're leaving outside.
I forgot to put it. I forgot to do the. I need one more thing for this. No. You do have it for the chain rule, but you also have to
Yeah.
have the
Well,
power
I'm
rule.
saying, like, so your u
3/2.
to be just what's under the bracket there. So your u is just what's under the bracket. So.
Oh wait a second. The u is just what's under the bracket, right?
Yeah, so that 1/2 doesn't stay there.
Oh.
Which is where the mistake is.
You are right, my friend. What happens to the 1/2?
That will stay there when we substitute it back in.
When we substitute it back in, but it's not there for the u. Okay, well, in that case, I don't think we got to do the chain rule then, but I did it anyway. That's the chain rule right there. If you had to do it, see?
Yeah.
Okay,
yeah, I remember that now. Okay.
Yeah.
Yeah.
Okay, anyway. Okay, scratch that. So that's good. So we just take the du of 3x to the, okay, so that's just negative 20 x to the 4th for me. I don't know what it is for you. Negative 20 x to the 4th plus okay, equals to du. And we want to get 2x to the 4th. What's up with this one, man? Are you having the same problem there?
What the heck? Oh no. I don't know. Oh, it's an indefinite integral? Crap. How does that work? I don't know. I'm confused now.
Yeah, an indefinite integral is going to be different, I guess.
Apparently.
Yeah. Because I don't see it matching up.
Yeah.
There. I get negative 20x to the 4th in mine. And
yeah, I don't know what to do about this one.
Question help? Help me solve this. 9 parts remaining. Okay. Oh, you got to go into g of x? Oh, shit.
Yeah, that's what I'm seeing.
All right. Maybe for another day.
Yep.
For another day.
Yeah.
That's what the weekend's for.
Yep.
No, man. I would stay longer, but that
yeah,
gotta go hike a mountain. Oh, if I die, I die.
Where are we supposed
to? All right. Okay, so right now I just stopped the broadcast. No, thanks again for all the help, and like I said, yeah, man, I really wouldn't mind that at all. Getting together and all that. Would you be able to get tomorrow?
Yeah, I could do tomorrow.
What time should I come over?
Let
me stop the broadcast.
I'm